Good afternoon, ladies and gentlemen in India, and good morning to all joining us from UK. Welcome to the webinar on Indian safety standards, whole body access, considerations, and risk reduction measures. My name is Abhay Singh, and I'm your host for today. We are joined by Eve Edwards and Malcolm Sharp. They sit on ISO Technical Committee and help draft these very standards. We also have Jordan with us to help with the questions at the end. Please use the Q&A function to post your questions throughout the webinar. We'll try and answer as many as possible after this is done, and send the responses to the remaining ones by email. Let's start. So at Fortress Interlocks, our purpose and vision is protecting people and protecting productivity. We do and manufacturing customized safety equipment at our manufacturing facilities spread across the world. Speaking about Fortress, our heritage, we have a long history of more than half a century, starting from UK. We now have offices and manufacturing sites at Australia, US, China, apart from UK. Indian operations started last year, and that is from where I'm coming to you. We have a very big range, starting from simple mechanical locks, solenoid-based locks, RFID access control locks. We have them in stainless steel, and they come with different certificates if you want them, like CE, ATEX, and different IP ratings as well. And to top it all, almost all of them are customizable to suit your specific needs. Now let's jump on to the standards. Indian Standards Institution was established in 1947. To a lot of people in India, we have come across with an acronym ISI or an ISI mark on a lot of stuff we use in our home, like a mixer grinder or a helmet for a bike and stuff like that. So ISI is actually an acronym for Indian Standards Institution, very different from what we have in its current form, Bureau of Indian Standards, BIS, which was established in 1986, the same year I was born. Okay, so that's two good things happening in that year, right? India is one of the founding members of ISO, as well as a member of IEC since 1911, and BIS is an active member contributing to development of international standards, also harmonize its standards with ISO. That is to make the Indian standards as similar as possible to the international ones, actually identical more often than not. ISO Technical Committee 199 is the committee which develops standards on the topic of safety of machinery. It is a committee made up of representatives from across the world. Fortress as representatives in America, UK, China, and Australia. Even Malcolm are one of those. All the machinery safety standards are copied directly over from the ISO once, word for word, world over. The biggest few are in the list with their ISO and Indian standard numbers right there. I hand it over to Eve from here to take you a bit more in detail for these standards. Please, Eve.
Thanks, Abhay. So what we wanted to just cover in this webinar, because we unfortunately don't have time to go through all of the standards as much as I would love to do that. So we just wanted to look at whole body access, because I think that's a really important thing. And it actually is covered in part in several different standards, so we can talk about a few different standards. So firstly, how do you define whole body access? And for that, we're going to look at ISO 13857, where it has the size of gaps through which a human body may pass. And so that's slots which are 180 millimeters or wider, or any openings which are 240 millimeters or wider. And for reference, that's about the size of a beer bottle. So if you can fit through that, then that's considered whole body access, because you're physically able to get through, and those sizes are defined in the standards, and then that's also carried through into other standards as well. So when you're going into that area through those openings, as you can see on the screen there's a ton of different names which are given to this area depending on which standard you look at. And this is a bit ridiculous. If you look at it, it could be a hazard zone, a hazardous area, a danger zone, a safeguarded area, etc., etc. And actually, what they've kind of tried to do now within ISO is to standardize this, because there is no one term. They're trying to standardize so that everyone uses the same term. And that term that they want to use is safeguarded space, because space is definitely better than area, since area sounds like 2D, space would be 3D, which more accurately describes what you're trying to safeguard. So that's what we're trying to go into. What does whole body access, how is whole body access defined? Again, these are proposed definitions because it's only quite recently that they've realized it's not been defined very well so far, but these are proposed in standards which are in the process of being rewritten as we speak, so should be released as soon as they're able to meet again. So whole body access is a situation where a person can be completely inside a safeguarded space. And I think the keynote to that is that it can be completely inside. So that's when there's a gate and you're meant to go in, but also if you could sneak through on a conveyor, or if you could get even inside, for example, a large press, if you could get behind that light curtain at the front of the press, if you can get fully in behind that, then that is also whole body access, and you need to consider it as such. So if you realize that you have whole body access, the next thing is obviously to work out what you may want to do about that. And the best way to work out what you're going to do is to look at your hierarchy of controls. This one is taken from ISO 12100, which is the IS 16812. And it's hopefully fairly common sense. So the first thing that you try to do is completely design out or eliminate the risk. In the context of whole body access, that would mean removing the possibility of accessing the area at all, removing the dangerous machine, or just making it so it's not possible to access. Obviously, that's not always possible or practical, so the next thing that you would try and do is use safeguarding. That's usually guards and control devices. And in the case of whole body access, that means detecting people inside. So it's anything that's kind of done without human intervention to prevent people coming into contact with a hazard. And then finally, if that's also not possible and people really do have to get in and up close to the hazard, then the next thing to do is information for use. So that's loads of different things, basically anything that involves human intervention. So asking them very nicely to do what they're told. So now we're going to look at the first thing. So if you're not able to completely eliminate the risk as per the top of the hierarchy, the next option is to use engineering controls. And so that's going to mean presence sensing in this. So light curtains often come to mind, but they're not great for large areas because they're usually only planar or even single beam. And so you could get places you could be undetected. So then you can look at laser scanners, which is that second picture, vision-based systems, things like that, and they're useful for big open areas, but you do need to take care with reflective surfaces, ambient light, or any large objects which may create blind spots and allow people to circumvent the detection zone. That's a key thing to consider. You can also have safety mats, which are another thing that could be useful for detecting presence. Again, you do need to be careful that they can't, people couldn't maybe be standing on other objects, or that there's any areas which aren't covered. That bottom right picture, the little blue box, that's actually radar, and that can detect movement as small as a heartbeat. And it's much less susceptible to interference from light and dust. So for manufacturing environments, that's often a really interesting option, and it's something that we've been actually working on, and that's in our test cell, our demo equipment area in our Wolverhampton office. So that kind of covers presence sensing. The next thing that you're going to want to look at is if someone has to go inside, then what are you going to do to make sure that an unexpected startup is prevented? So there's an entire standard about unexpected startup, ISO 14118, which is the IS 16813. And for that, it suggests some locking devices. So basically, these are all things that can give individual control, so that the person going inside the area kind of proactively is stopping you being able to restart the machine. And that's the key thing. It's giving that person control, and then also kind of peace of mind that if they're going inside, they aren't going to, the gate's not going to be locked on them, and the machine won't be restarted while they're inside. And so ways of doing that are trapped key systems using safety keys, which we'll explain in a bit more detail. You can also use padlocks, as are shown there, interlock blocking, things like that. And then you can also have lockable housings. You can have boxes that go over things. Another key part is, the other way of doing it is to use a maintain stop command. So that's, as it sounds, making sure that the stop command on the machine is maintained, so you cannot turn the machine back on until the person who's gone inside actively releases it. So that's often using latching or key operated devices, or you can have lockable covers over the buttons so that you can't restart. It's worth noting that emergency stop buttons are not allowed to be used in this manner. They're for emergencies only and not for maintaining a stop command. And I think with that, I'm going to hand back over to Abe, who I think is going to show you a video now.
Thanks, Eve, for that. So we have a small video here. Sorry, give me a minute. There's a problem. Okay, works now. We have a small video here representing. We have a small video here representing the trapped key interlocking, which is one of the safeguarding methods. You see a robot which is inside a safeguarded area and needs to be accessed either for maintenance or for teaching or for programming. Now, if this needs to be accessed, then access key is used to power off the robot. Same key then goes into the key exchange box, which is at the door of the guarding. After the access key is inserted and turned inside that door exchange, safety key is released and extracted in order to open the door. The personnel goes inside with safety key on him to do his work. He can't be logged out and the robot can't be powered on, as the access key is trapped and won't be released unless the safety key goes back inside the key exchange door. When the work is done, it comes back, does the cycle in reverse, the access key, the red one, which can go back again at the panel, and the power can be turned on. So as we saw in the video, that the access key is trapped until the safety key is back in the exchange fixed at the door. This is completely mechanical, so no wiring at the door. There are many different systems and options possible, using key exchange devices, releasing multiple safety keys, using solenoid release keys rather than mechanical ones. We can even have the RFID cards for access control, allowing only the authorized personnel. Something very useful in high value cage protection at warehouse or e-commerce operations. This is all as per Indian standard or IS 16813. In the video, which was shown a minute back, you might have noticed that a flap or a bar comes down after the safety key is removed. What's being done here is that we are forcing the personnel to take the key out completely and not just turning and leaving it in the key exchange, which would have given an opportunity to someone else to turn the power back on, and a normal maintenance job would have become a disaster, only by mistake. Fortress has developed the means of forcing extraction of the safety key, removing as much requirement of the humans to do what they are told possibly. Extracted key will not allow the gate to be opened until the key has been removed and the flap lowered, stopping people from just turning the key and not actually taking it. We are currently developing a new product which allows forced extraction safety keys to be retrofitted to doors having solenoid locks of any make without changing any of the wiring or control system logics. So if any of you or your solenoid lock based locks needs retrofitting with least hassle, you know whom to contact. That would be me. Safety keys are not always practical. That's actually a fact, right? So especially in scenarios when a lot of people need access. So interlock blocking becomes another method of providing individuals with personal safe control, whether the gate can be locked and therefore hazard reset and restarted. Currently, part of the committee draft of ISO 14119 recognized as means of preventing unexpected startup. The interlock blocking device itself is neither considered as a part of the interlocking device or nor the safety function. This is something which we need to keep in mind. Individual padlocks on either the head or handle of an interlock to stop the gate from being locked closed. This gives personal control to every person who puts a padlock on. Please note that this is actually not LOTO. The risk assessment process may identify the need of supplementary release of guard locking. This is as per IS 16812 and IS 16819. Deliberate unlocking of the door of the guard locking from inside of the safeguarded area shall be easily possible without auxiliary means and regardless of operating conditions. The unlocking means shall be manually operated and act directly on the principle of locking the mechanism. The unlocking shall generate a stop command, that is stopping everything. The unlocking should also means for the escape release shall only be accessible from inside the safeguarded area. There may also be a need, if you realize, to consider whether it is necessary to have means of access from outside to get in, let's say, an emergency. If someone is trapped inside by mistake, or due to a medical emergency, the person collapses or there's a fire. So we can have an emergency release, which can give you an override from outside without any auxiliary means. Now, you can also have an auxiliary release option, wherein if power fails on a power to unlock device and access is required, so you can override the device through a special key or a device from outside. If you recall the hierarchy explained by EU earlier, this is the least preferred method of risk reduction as per ISO 12100 or IS 16813, ISO 14118 and IS 16813. Signaling and warning, delayed start. This also finds mention in American standards B1119 and B1120, commonly known as just B11 standards. A warning signal and delayed startup shall be provided when all danger zones cannot be seen from the operator control. From the operator control station, or when the presence of persons in danger zones cannot be detected or excluded. Warning period to be long enough to exit or prevent startup by initiating emergency stop. Where applicable, machinery should provide an indication of different states related to startup. For an example, waiting for a start command, waiting for material, power on, etc. Now we are almost done through the presentation which we had. We just have got a couple of more examples to see how this works in the real world situations. So the first one on the line is construction materials dehacking line. Dehacker takes bricks out of a kiln and stacks them into neat piles on pallets. Here we have a Fortress M guard, which is a solenoid based lock. Operator presses request to enter. Once the machine is shut down and it is safe state, the safety key can be removed, forced extraction key, so that it is taken by the operator, as we saw in the earlier slide and the video. Interlock blocking is also available on handle if more people entering at the same time or need to access it at different times as well. Escape release is also integrated into the handle. This one, which is a third-party logistics robotic palletizer, would be of particular interest in India, as we have big warehouses of Amazon, Flipkart, and other e-commerce functionaries where the warehouse size is up to 2 million, 3 million square feet as well. So the example which we have here has a combination of different measures in normal operations. Crossing the light curtain will immediately stop the robot. When access is required, request access with the push button, which will make the robot safe, then release the key and deactivate the light curtain. While the key is being held, the robot cannot be restarted These can then be used to initiate teach mode or within the cell if required. So that's all we have. Thank you all for your attention. I hand it over to Jordan for the questions we might have received. Thank you.
Thank you so much, Abhay and Eve. And we have plenty of questions to be asking you both. The first one is that good, Malcolm?
Thank you. Yep.